Welcome back to my YouTube channel, and in today's video, I'm going to be solving a series. I'm going to be solving a series of questions from the past question of Masano 3 2018-2019 states. So, in the past question, I'm going to be solving it, and um, follow me for more past question answers, for more answers to past questions like this. Thank you very much. So now, the question 1A of the Masano 3 past question says clearly define the following terms: odd function, even function, domain of a function. Hence find the domain of f of x is equals to the square root of 4 minus x square. So now they ask us to define a odd function and an even function. Now, what is an odd function? An odd function is a function whereby f of x is equals to f of minus x, like this, whereby f of x of that function is equals to minus f into minus x. Now, this is an odd function. Once you have f of x and you have minus f of minus x as the same thing, the function is odd. For example, let's say x cube. So x cube. So now we have x cube as f of x, f of x, f of x is equals to x cube. Now, and we have to find for minus f of minus x, minus f of minus x. It has to give us x cube also. Like it has to give us the value at which x cube gives us. So now let's say that this f of x as x cube is f of 2. We have f of 2. So we find for 2 cube, that is equals to 2 raised power 3, which is equals to 8. But here we have minus f of minus 2. Doing the same thing using x-ray, so that it will be equals to minus 2 square, then you put the minus, minus 2 cube, then you put the minus outside. The minus will be here. So we have minus, open bracket, minus 2 cube. So now if we simplify this, we have this as minus 2 cube is equals to minus 8. So minus times minus 8 is equals to 8. Therefore, x cube is an odd function. So that is for odd function. Now for even function, f of x must be equals to f of minus x. That is the street for even function. That is how to test for an even function. An example of an even function is equals to x square. So if we have x square right now, so we have it as f of x is equals to x square. Therefore, f of minus x must also give us the same value at which x square is going to give us. Let me take 2 for an example. Let's say x is equals to 2. We have f of 2 is equals to 2 square, which is equals to 4. But we have f of minus 2. So we have minus 2 square is going to give us 4. That is why x square is an even function. That is for even functions. So now let's move to the domain of the function. Now, the domain of a function is the total amount of real numbers that can come out of a function, that can come out of an equation. That is, for example, let's say x square plus 1. In this equation, any number you put into x will always give you a real number. That is, it will not give you something like undefined or infinity or I as imaginary unit or something like that. Any number you put here is going to give you an it's going to give you a real number. So the domain of a simple function like this usually ends up being from minus infinity to infinity. That means all the numbers in between is always it will always give you a real number. So now let us take this for an example as what they give us. The domain of a function, find the domain of f of x equals to square root of f of minus x square. Now we have square root of 4 minus x square. Now what are the ways that the type of things that can be inside this square root that is going to make it give us undefined or imaginary numbers is if the thing inside the square root is negative. So let's say we have square root of minus 1. The square root of minus 1 is undefined, or it can be written as I, which is an imaginary unit. So we do not want imaginary units. We are looking for the total amount of real numbers that we can find inside here. Anything negative will not work. So therefore, we get it as 4 minus x square must be greater than or equals to 0. That means from 0 upward will always give us a real number. So therefore we use it to find for the value of x. We have minus x square is greater than or equals to minus 4. So if we bring them both, we have 4 is greater than or equals to x square. Find for the square root of both sides. We have 2 is greater than or equals to x. Therefore x is lesser than or equals to 2. So now the domain of the function is x is lesser than or equal to 2. So if you want to write it in standard form, if you are going to be writing this in standard form, you are going to be writing it as from you can write it as minus infinity is lesser than x, and x is lesser than or equals to 2. That means the total is from minus infinity to 2. So this is the domain of the function 4 minus x squared.
So right here in the 1b of the past question, the 1b says determine whether the following functions are even or odd. The first function is f of x is equals to x square, and the second function is f of x is equals to x cube. Now they ask us to determine whether the following function are odd or even. So in the one I have earlier said, I've earlier said that to find if a function is even, we use the formula f of x is equals to f of minus x. So if f of x is equals to f of minus x, that means the function is even. But if the function is like this, f of x is equals to f minus f of minus x, that is minus f of minus x, that means the function is odd. So this is even and this is for odd. So now we are going to be testing it on both. Now let's start with I. For I here, let's take x. Now let me pick the first one. Let me start with the first one. We have f of x is equals to um x square, right? X square. Then what is f of minus x? Simple. Whenever you see x, you put minus x. So we have minus x in brackets all square, and minus x in square is equals to something like minus x times minus x. So here we know minus times minus is equals to plus, and x times x is equals to x square. Therefore f of x is equals to f of minus x. So therefore it is even. As it is even. While for the second one, I'm going to start by checking if it is even first. So I the second one, f of x is equals to x cube. So what is f of minus x? f of minus x is equals to minus x raised to power 3, and minus x raised to power 3 is something like minus x times minus x times minus x. So if we do minus x times minus x, we have x squared times minus x, and this is minus x cubed. So here now, f of minus x is the same thing, is not the same thing as f of x. F of x is x cubed. F of minus x minus f of x f of minus x is equals to minus x cubed. So that means it is not even. So now we are going to check if it is odd. So f of x is x cubed. Now to check if it is odd, we use the second one, which is minus f of minus x. So minus f of minus x, we have equals to, we have minus x cubed with the minus at the back, which is the minus that is coming with the function. So minus x cubed is the same thing as, minus x cubed according to how I did it earlier. So the minus times minus equals to plus. We have x cubed. Therefore, it is odd because minus f of minus x is equals to f of x. Therefore, it is odd. So this is an odd function. So now in the question 2a, it says if f of x is equals to 2x squared minus 5 and g of x is equals to 4x minus 2, find FOG of x and I find GOF of x. Now FOG of x, what is FOG of x? FOG FOG of x is the same thing as f in brackets g of x. That means a function inside another function. As g of x is the f is a function of g, which is also a function of x. So how do we solve something like this? So now let's take um, number I, which is FOG of x. So now we have our f of x as 2x squared minus 5 and our g of x as 4x minus 2. So what is our FOG of x? Now, since I say the FOG of x is equals to g is equals to f in big brackets g of x. Now, that means f is a function of g of x, right? So what is our g of x? Our g of x here is equals to 4x minus 2. So therefore, this is the same thing as f of 4x minus 2. So this is what we are looking for. So now we have our f of x. Since our f of x, so we have our f of x equals to 2x squared plus 5. So when we are doing function, they told us to find for f of 4x minus 2. So when we put it here, we will have FOG of x is equals to 2. Now the x here will be replaced by 4x minus 2. So we'll put in brackets 4x minus 2 all squared because the x there is squared, then minus 5. So we try to expand this. We have 2 in brackets 4x times 4x 16x squared. 4x times minus 2 minus 8x minus 2 times 4x minus 8 minus 8x minus 2 times minus 2 plus 4. Then we have our close bracket, we have minus 5. We continue expanding. 2 multiplied by 16x squared, we have 32x squared. Then minus 8, 2 times minus 8, we have minus 16x minus 16x. 2 times 4 plus 8 minus 5. So we have this is equals to 32x square minus 16x minus 16x, that is minus 32x. Then 8 minus 5, we have plus 3. So our final answer here is equals to 32x square minus 32x plus 3. That is the answer for FOG of x. But what about the second one where they told us to find for GOF of x? So now GOF of x is similar, something similar. We have GOF of x is equals to G, that means f of x is a function of g in here. So in GOF of x, that means what is f of x? F of x is equals to 2x square minus 5. That means this is equals to g in bracket 2x square minus 5. But if g of x is equals to 4x minus 2, what is g of 2x square minus 5? That means we are replacing what is in x here with 2x square minus 5. So we have g o f of x is equals to 4. When we have x, replace it with 2x square minus 5. We have 2x square minus 5. Then we have our minus 2 here. Expand it, we have 4 times 2x square, 8x square. 4 times minus 5 minus 20, then we have minus 2. So our answer here is 8x square minus 20 minus 2, that is minus 22. So right here, this is our final answer for this, for finding for GOF of x. So now the number 2b of the past question says evaluate the following. I, limitation where x tends to 2, x square minus 4 over x minus 2, and I, limitation where x tends to infinity, 3x minus 4 divided by 6x plus 2. So this is what we have to solve here now, the number I. Now you will notice that if we just directly do, if we do a direct limit whereby we are just imputing 2 into the whole equation there, we are going to get something that is not valid. Let me show it to you. Now limitation x tends to 2 for this, we are going to have 2 square minus 4 over 2 minus 2, which will be equal to 0 over 0, and anything divided by 0 is equals to infinity, the same as undefined. So it's going to be undefined, and we do not want an undefined answer, we want a real answer. So in order to get a real answer, we are going to find for the difference of the squares. Now let me write the question. We have limitation x tends to 2 for x square minus 4 over x minus 2. Now in order to, we can find for the difference of two squares of this. Now using the difference of two squares, x square minus 4 can be broken down into x minus 4 times x plus 4, using the difference of two squares. If you are familiar with little bit of quadratic equation, so we can break it down into this form. Therefore I'm going to be write um difference of two squares. If we are going to break down this, we are going to have something like x square plus 2. We are going to have something like x plus 2, because we are finding for the square root of both sides, both x square and for 4. So x is in two places, which x times s, and 2 times 2 would give us 4. So we have x plus 2 times x minus 2. If we multiply both of them together, we are going to get this, and I got it using the difference of two squares. So now this here is what we are going to impute into this equation here. We are going to have limitation where x tends to 2 of x plus 2 times x minus 2. Then we close our brackets, x minus 2. So we have x minus 2 here and x minus 2 here. That means x minus 2 here can cancel x minus 2 here. Then we are going to have it as limitation x tends to 2 of 2 of x plus 2. Then when we impute our limits, we are going to have x equals to 2. We have 2 plus 2, which is equals to 4. So our final answer is equals to 4 for the I. While for the II, we are going to use a more different approach. For the II, we are using a more different approach. Let me write, we have limitation, limit of x tends to infinity, 3x minus 4 divided by 6x plus 2. That is what the question is. As obvious as it is, if you put infinity into these equations, you are going to be getting undefined answer. Infinity minus 4, infinity minus 2 is not going to make sense. So for us to be able to get a real answer, we have to divide everything by the value of x with the highest power. Like for example, if there is x square inside this equation, we are going to be dividing every single compartment with x square. But since it is x that has the x is power 1 that has the highest, as the x with the highest power, we are dividing everything by x is power 1. So here we have it as 3x divided by x. Then we have our minus 4 over x divided by 6x divided by x, and we have plus 2 over x. So this is simply how we are going to be putting it. Simplifying it, x cancel x, x cancel x. We have it as equals to 3 minus 4 over x divided by 6 plus 2 over x. So then we can put our limits here into it. Once we put our limits, we would have it as 3 minus 4 over infinity divided by 6 plus 2 over infinity. So now here you might be a little bit confused about how we are going to be dividing this, but it is as simple as anything divided by infinity is equals to 0. How did they define that? When we have something like anything divided by 0, let me take x for an example. X divided by 0, that is anything, is equals to infinity. So if we just do the one-way crossing, bring this here, bring this here, we have x divided by infinity, anything divided by infinity equals to 0. That is mostly how it was. That is how it was derived. So simply anything divided by infinity here will give us 0. So we have this as 3 minus 4 divided by infinity 0, 6 plus 2 divided by infinity 0. This is equals to 3 over 6, which is equals to 1 over 2. So 1 over 2 is our final answer for this limit. So in the question 3a says differentiate y is equals to x square plus 2x plus 5 using the first principle. That is using the first principle. So using the first principle, the first thing that we have to do, the first thing we have to do to know is that when we are using first principle, y here is going to change to y plus delta y, and x here is going to be changing to x plus delta x when we are using the first principle. So that is what you need to know using first principle. So using first principle, we are writing that we have y plus delta y is equals to, in brackets, x plus delta x all square plus 2 in brackets x plus delta x, and we have plus 5. Simplify this, y plus delta y is equals to x square, x times x square, x times ax, we have x ax plus x delta x, then delta x times x plus x delta x, then delta x times delta x, we have plus delta x square. So plus this one, we have plus 2x plus 2 2 delta x, then plus 5. So after simplifying this, let me simplify it a little bit more. We have this as x square plus, then x delta x plus x delta x, we have it 2x delta x, then plus delta x square, we have plus 2x plus 2 delta x plus 5. So after this, we have y plus delta y equals to this. Then we are going to be making delta y the subject of the formula here. Therefore, y has to come here. So we have delta y is equals to x square plus 2x delta x plus delta x square plus 2x plus 2 delta x plus 5 minus y. It doesn't stop here. We don't just leave y here. We are going to, back from the equation, we have y is equals to this. We are going to bring back what is inside y, which is x squared plus 2x plus 5 back into this. So we are going to be having delta y as x squared plus 2x delta x plus delta x squared plus 2x plus 2 delta x plus 5 minus, in brackets, whatever that is here before, we have x squared plus 2x plus 5, then we close our brackets. So opening the bracket, we have x squared plus 2x delta x plus delta x squared plus 2x plus 2 delta x plus 5, then minus, opening the bracket, we have minus x squared minus times plus 2x, we have minus 2x, then minus times plus 5, we have minus 5. So here we have plus 5 and minus 5. Therefore, they go away with each other. We have minus 2x, we have plus 2x, they go away. And we have minus x squared and we have x squared here. So they go away. So what is left of it is that the delta y is equals to 2x delta x plus delta x squared, then plus 2 delta x. So this is what is left of the equation. Now, if we are continuing, we are going to divide all the sides by delta x. So we have delta y over delta x. Delta y over delta x, divide everything by delta x. We have delta x here divided by delta x, and here divided by delta x. So delta x here cancel delta x, meaning leaving 2x. Delta x here cancel one of the delta x here, leaving only delta x. And delta x here cancel delta x here, leaving 2. So let me look for a little bit of space. So now, whatever we got from this is delta y over delta x is equals to 2x plus delta x, then plus 2. So dy dx here is not the same as delta x. Dy dx is equals to delta y over delta x limits when delta x tends to 0. That is when it becomes dy dx. So therefore our dy dx here is equals to 2x. Delta x here tends to 0, so we have plus 0 plus 2. If our final answer will be equals to 2x plus 2. So this is differentiation using the first principle. So now the question 3b says if y is equals to arc sine of x, find dy dx. So how are we looking for dy dx? First of all, you say y is equals to arc sine of x, and we know that if arc sine, it means that y is equals to 1 over sine x. This is what it simply means. This is what it simply means. So here we are going to be using the quotient rule. Above one as u and this as v. Therefore, we have our u is equals to 1, then our v is equals to sine x. So du dx is equals to 0 and dv dx is equals to cos x. So and the formula for quotient rule is dy dx is equals to v du dx minus u dv dx divided by v square. That is the formula. So we have our v here as sine x. We have sine x times du dx, which is 0, minus u here, which is 1 times dv dx, which is cos x, divided by our v, which is sine x, then square it, sine x whole square. So if we simplify this, we have dy dx is equals to sine x times 0, we have 0 minus 1 times cos x, we have cos x, divided by sine square x. So our final answer will be equals to minus cos x over sine square x. So this is our final answer.